Homer Simpson today. There he is. Okay, so here we have to make sure. So we're just going to go through a few of these slides. I'm not going to go through everything, but the first, how do I make this work? I have to go like that. There's Homer. There he is. Okay, but moving on from Homer, this is what we'll learn. How to analyze and sketch graphs of rational. We kind of learned that already, but we're going to learn how to sketch ones that have slant asymptotes and use graphs of rational function to model and solve real life problems. So there is one example of that at the end. So the graphs. So here are there's 7 steps. Okay, and I posted this. I posted the 7 steps also on my Schoology. So here's the first 4. Okay, this is basically the steps you would take to graph a rational function. If you want to write that, who wants to write that down? Okay, I'm going to have some coffee here. I'm going to pause. So, whoops, did I pause it? No, pause. I never unpaused. Sorry guys. So, so there. Can I go on now? No. So what I just said, for those of you who weren't hearing me when I was talking, plot each one's point beyond and between each x-intercept, and use smooth curves to complete, and excluding any points where f is not defined, which means the holes in the graph. Okay, I'm going on. So we're going to do one. Okay, here we go. Next one. Sketch the graph by hand. Okay. So first of all, you want it. So we're going to go through these steps. First, you want to. What's the first thing you want to do? Find the y. No. Simplify. Okay. Can this be simplified anymore? You can't. So unless it's something to be factored, you just leave it alone. Okay. So 3 over x minus 2. There's no simplification. Then I want to find the y-intercept, right? Y-intercept. Who can tell me what the y-intercept is? How do I find the y? You plug in 0 for x, and you get out negative 3 over 2. Okay? Yeah? What? Yeah, but you don't have to graph everything exactly. X-intercept. Who can tell me what the x-intercept is? There is none, because to find the x-intercept, you set the top equal to 0. Well, the top is never going to be equal to 0. The top's always going to be equal to 3. So there is none, okay? There's none, because if this can't be, if you can't turn this into 0, then there's no x-intercept. What was the next thing? Vertical asymptotes? Is that next? Yep. Vert asymptote is when the denominator is equal to 0 and can't be canceled out with something at the top. So what is a vertical asymptote? 2. X equals 2. Okay? Now you have to find the other asymptotes. Is there a horizontal asymptote? What is it, Sydney? 0. Okay. Horizontal, y equals 0. And the reason for that is because the degree of the bottom is bigger than the degree of the top. This is considered degree 0. Okay? This is considered degree 1. Okay, because its exponent is 1, this could be written as 3x to the 0, right? Okay, if you really wanted to put a coefficient up there. Okay, and then it said, so the next thing says to plot points in between. I would suggest first doing the graph, okay, and then plotting points in between, okay, or first putting in what you know, okay? So I'm going to sketch in my asymptotes first. At x equals 2, I now have a vertical asymptote. We should change colors, right? X equals 2. So here's a vertical asymptote at x equals 2. And I have a horizontal asymptote. Here is the y-axis. But also I know that this goes through the y-intercept. So this is 1, 2, right? And the y-intercept, 0, negative 3/2. So here's 1, here's 2. So I know it goes through there. Okay? And I know that the y-axis, or the x-axis, sorry, is an asymptote. So if this line is an asymptote, it goes through this point, and this line is also an asymptote, I know at least on this side that my function has to be looking like this. Yes? Yeah? You guys get that? What do you think it looks like on the other side of the asymptote? It does, yeah, it kind of looks like this, okay? As far as, so the last step says to plot points on the left and right side of the x-intercept. I don't always have to do that, but if you don't know whether it's down here, so since these are both asymptotes, it might be down here. That's probably not going to be the case, because only that time that happens, if this is like squared or something. But, so if I want to find out where it is, I plug in another point. What's a point to the right of 2? 3. So if I plug in 3 into my function, what do I get out? I get out, no, 3. I get 3 over 1, which is 3. So there's a point on my graph that's 3, 3, right? And so that kind of confirms that this is an asymptote, and it goes through 3, 3, and this is an asymptote. Then over on the other side, it's going to be looking something like that, okay? So that's how you sketch it. Again, if you don't know what's happening to one side or in between or something, or to the left side, that's where you plug in a point to see which side of the x-axis is on. So we're done with that? Easy enough? Okay, it gets harder though. Sorry. Whoa. Am I still going? I'm still going.
Yeah.
I haven't talked that much so far, have I? Oh, we don't have to go through all this. There, we did it right. Slant asymptotes. Slant asymptotes, also known as oblique asymptotes, okay? Slant asymptotes, where'd that go? Sorry. Also known as oblique asymptotes, happen when the top is 1 more than the degree of the bottom, okay? And I'll kind of talk about algebraically why that happens, okay? Consider rational functions. Don't write all these words. Just say if the degree of the top is bigger by 1 degree than the degree of the bottom, then you have an oblique asymptote. Moving on. I'm moving on. You could. So in this case, for example, okay, for example, x squared minus x plus 1. The degree of this is 2. The degree of this is 1. The way I find see this one? This is called an oblique asymptote, or a slant asymptote. The way you find that is by dividing this into, you divide the top into the bottom, and you have to use long division, otherwise you won't get the entire equation of your oblique asymptote. So if I were doing a long division with this into this, the good thing is you only have to divide twice. You only have to do 2 steps, because if this is 1, I'll show you what, okay? So what do I multiply this by to turn it into this? What goes up here? X. So you're going to put an x up here, right? Because x times this makes x squared plus x. And then I subtract this entire thing. This disappears. I get negative x minus x, which is what? Negative 2x. What do I need to multiply this by to turn it into negative 2x? Negative 2. 2 times this makes negative 2x. 2 times this makes negative 1. Okay? I could bring down a 0 here if I want to.
You mean
Negative 2, sorry. Negative 2, I said. Negative. So this times this gives you negative 2. So when I subtract this minus this, I get 2. So this is, so x plus 1 goes into this x minus 2 remainder 2 over x plus 1, right? Because it's 2 divided by this. But the reason you have a slant asymptote is because as x gets really, really big, this function looks like y equals x minus 2, okay? And you only have to go 2 steps, because once you're at the equation of a line, you're done, right? This is the equation of a line. And what happens with the remainder, if x gets really, really big, what happens to this remainder? What does it turn into? What's 2 over a huge number? What's 2 over a huge number? 0, okay? So this turns into 0, right? And so you end up getting just this equation, y equals x minus 2, which is the equation on the left. Some people ask in the last class, what happens if I have like x cubed on the top and x squared, x to the first on the bottom? Then it actually approaches, as you get really big x's, it actually approaches x squared, or a parabola. But we're not going to worry about that. You know what I mean? Okay? So, no falling asleep. Come on, don't fall asleep. We're going to do an activity. You're going to wake up. All right. So, do you have any questions about that? So, the other thing is you can't have both a slant asymptote. So the way you graph it, so this means you have a slant asymptote of y equals x. Here it is, y equals x minus 2, right? Y-intercept of negative 2, a slope of 1, okay? And a vertical asymptote at x equals negative 1. You can't have both a slant asymptote and a horizontal asymptote, because if you did, then it wouldn't be a function. You understand? Okay? Because a function has to pass a vertical line test. So you can't have, so either you have a slant asymptote or you have a horizontal asymptote, but you can't have both. All right? So you need to understand that. Okay? But you can have more than one vertical asymptote. So in this case, we have a vertical asymptote and we have a slant asymptote. You could have 2 slant asymptotes. We're going to do an example in that. I mean, you could have 2 vertical asymptotes. Okay, so example. Here we go. We did that. So sketch the graph of this. So we're going to go through those steps, and then we're kind of going to be done with this part of it. Okay? So your first step should be to simplify this. What does this simplify to? What does the top turn into? X. You have to know how to factor. This is why you took algebra. X minus 2 times x plus 1, right? And on the bottom you have x minus 1. Does anything cancel out from the top and the bottom? No. If this were a minus 1 up here, then you'd cancel it out, and then you'd have a hole at x equals 1. But we don't, so it just... so what's the y-intercept? And in the last class, I told them, so to find the y-intercept, you plug in x equals 0. But usually it's easier to plug in 0 into the original equation rather than into the simplified equation. What do I get if I plug in 0 in here? 2. You guys see that? Okay. Negative 2 over negative 1. It's easier to plug in 0 in here than in here, because then you have to multiply and divide, right? Okay. X-intercepts. There's 2 of them. What are they? 2, 0. That's at x-intercept. This one, y is 0. And what's the other one? Negative 1, 0. Those are the x-intercepts. What else do I have to find? Vertical asymptote. What's a vertical asymptote? X equals 1. Okay? Is there a horizontal asymptote? No, there's a slant asymptote. Do you understand why there's a slant asymptote? Because this is 1 degree bigger than this. So now you gotta do some math over on the side. So you do a little long division problem. It's not that bad. X minus 1. And again, you only have to do 2 steps. You do x squared minus x minus 2. What do I need to multiply x by to turn it into x squared? X. That goes up here. So this times this gives you x squared minus x. And then I subtract that entire thing. What do I get when I subtract that entire thing? You get 0. Just 0, right? And you can bring that down, negative 2, right? How many times is x? So what do I need to... So what do I need to multiply x by to turn it into negative 2? I can't, right? I'm done, okay? So you have a remainder of, if I did this, there's nothing I can really, so I have a remainder of negative 2, okay? So y equals x is my slant asymptote, because there's no constant part of that. And now I sketch a graph. Am I going too fast? Sarah? Y equals x, because when I divide this into this, all I get is a remainder of 2, and this doesn't go into 2, right? So I'm done at this point. So I really only had to do one division, right? This into this one time. Okay? So now we're going to graph it. Ready? Oh, that's not very good. Let's make it solid. Solid, man. So I'm going to graph all my points. Vertical asymptote at x equals 1. We're going to make that dotted. Dotted, different color. X equals 1. Here's x equals 1. What does y equals x look like? Y equals x. It goes like this, right? Y equals x. I know I have x, so this is y equals x. This is x equals 1. What else do I know? I know I have a y-intercept at 0, -2. 1, 2. Okay? I know I have an x-intercept. I knew that. I just was checking to see if you were paying attention. Okay? What happened? I gotta go back. What happened? Make that go away. At 0, +2. 1, 2. Okay? So there's my y-intercept. And then x-intercepts at 2, 0 and at -1, 0. So 2, 0 is somewhere over here, and -1, 0 is over here. So using this, anyone want to tell me what my graph looks like? You don't even have to plug in any points. Yes, sir. Very good, Francisco. He did it like that. So it goes through these 2 points. This is an asymptote, and this is an asymptote. So it kind of looks like this down here. Kind of goes up and through and up like that over there. Oh, I can do that over there pretty nicely. Okay. And on the other side, since you know this is an asymptote, and it goes through this point, and this is an asymptote, it kind of goes up like this through that point, and it approaches this asymptote like that. Yes? No? Maybe? Okay? Okay. So, you like this? It is a nice icon. It's very colorful. Yeah. Even if they graph it wrong. Well, really, so all you have to do is find this point. Now it gets harder when you have holes and stuff, but we'll talk about that later. So there you go. We did it very nicely. We did it right. Long division. Y equals x is a sine asymptote. Look at it. Look at it. We did everything right. There it is. Perfect. Application. Don't write this down. I just want to show you that there are some applications of this. Okay? And I didn't assign a problem like this. So a rectangular page is designed to contain 48 square inches of print. The margin each side of the page have to be 1.5 inches wide. The top and bottom have to be 1 inch deep. What should the dimensions of the entire page be so that the minimum amount of paper is used? So what they do is, this is x, this is y. This needs to take up a certain area. So x times y equals 48. And this kind of like that problem that you had on the test. X times y has to be equal to 48. And then x plus 3 times y plus 2 gives you the area of the whole thing. If you look backwards, okay? Where did we go? Where did we go? Sorry, go back, go back. So the area of this whole thing is x plus 1.5, and 1.5 is x plus 3. And the area of this way, this is the thing that I'm trying to minimize. Remember, minimize, what am I trying to minimize? I'm trying to minimize this times this, okay, which is the area. Very similar to that problem that you guys had. So what you usually have to do with these, they give you one restraint, and they say the area of the inside thing is 48, and you solve that for a variable. And then what's kind of cool here, when you plug this in, you get a rational expression, okay? And if you graph this one, this has a vertical asymptote. They just tell you to do it with your calculator, but if you did graph this, you get something that looks like, this over here as a slant asymptote here, and then I think the other half of it looks kind of like this. No, what does it look like? It looks kind of like this. So you have a maximum here and a minimum here. Actually, this one's going this way. You have a vertical asymptote at 0. That's right. So it looks more like this, kind of like this. But this is a maximum and this is a minimum. And you can use your calculator to find out where that minimum occurs. Okay? And because notice that this number goes down and then it starts going back up again. So your minimum occurs somewhere, whoops, your minimum occurs in between 8.4 and 8.5, because you can see it goes down and then it starts going up. Where does it go? It goes down to here, and then it starts going back up again. See how this is bigger than this? So right at about 8.5, you have a minimum. Anyway, I didn't assign that one. That's not your homework, okay? I changed it on Schoology, okay? So now what you're going to do, I'm going to stop. I'm going to stop, and I'm going to give you this activity because you don't want to sleep through the rest of class. Okay, so how do I stop this? How do I stop this?